Hello, I'm Arthur. Welcome to my lab. Today, let's talk about motors. This image here is a typical schematic image for a motor. More or less, this is what you'll see in a schematic if a stepper motor is involved. And every stepper motor has two coils, which are represented by these loopy things here. These are two coils, and each coil has two ends to it, two wires. One wire coming in to the beginning of the coil. This is the end of the coil. One wire coming out. Same here. One wire coming in, beginning of the coil, going through the coil, and coming out. And some stepper motors have actually a tap in the middle of the coil. So this is this additional wire here. This is a tap in the middle. And actually, for some of the wires, these coils are split into two separate coils, two individual coils, where you have wire coming in, going through half the coil, coming out, and then a separate wire coming in, going through the other half of the coil, and coming out. But we won't get into those today. The reason why you would want to have a motor like this is for added flexibility. You can then connect the two halves of the coil either in series, like this. This would be the equivalent circuit for two coils, two halves connected in series, or you can connect them in parallel, and then you get more torque, more speed. So basically that's why you would want to rearrange. But most of the motors that we deal with in 3D printers will have 4 wires, 2 per coil, or maybe sometimes 6 wires, 3 per coil, with this additional wire being the center tap. But really, we don't use center tap. All that matters is the wire coming in, wire going out. So I've labeled them 1A and 1B for first coil, and 2A and 2B for the second coil. And that's the symbols that you have in your typical motor driver board that you use for most of the ramps boards and Sanguino Lulu and what have you. And so that will be your A something something. I don't remember the chip number, but they're the very popular A boards, and the DRV8825 is the Texas Instrument chip that's used on some newer boards. And those chips are actually nicer. They have more microstepping. You can go to 32 microsteps with those DRV boards. So I highly recommend using those. And that's what I have in my test circuit. And so again, you have your 1B and 1A and 2A and 2B outputs from the driver board, and you connect 1B to the end of the coil, 1A to the beginning of the first coil, 2A to the beginning of the second coil, and 2B to the end of the second coil. So that's how you would hook it up. And usually the pins are lined up and arranged so that you can just use a straight wire going from your driver to the motor. But that's not always the true. Sometimes the wires are moved around and you have to rearrange them to connect them correctly. Before we get into that, though, let's talk about what happens when you have a Prusa i3 or any kind of Prusa design which uses dual motors for your Z-axis, or Hypercube, the oversized type that also you could use 2 motors for your Z-axis to lift your bed. If the bed is larger, it's a good idea to have 2 motors on either side or on the back and front of the bed. So you have 2 motors. Each has 2 coils, so that's 4 coils. But let's take a look at just one coil for each motor, because the other half would be connected exactly the same. So let's take coil number 1 with inputs 1A and 1B, and you have 2 motors, so we have 2 coils with 1A and 1B. And let's say that 1A is a blue wire and 1B, the output, is a red wire. Take a look at this specific motor right here. This one actually happens to have a blue and yellow wire for one coil and green and red for the other coil. So so let's use this pair. Let's pretend that this yellow is red, which is what I used for the labels in my schematic. So we have blue and red. And so you have two motors like this, and you want to connect them. And there are two ways you can connect these two motors. Either you can connect your individual coils from both motors in parallel. So this is your one coil from one motor, and this is the other motor, and they are connected in parallel. The two blue wires are connected together and go to 1A on your driver board, and two red wires are connected together and go to 1B on your driver board. So that's one option, and the other option is to connect them in series, where one coil from one motor gets connected to the second coil from the second motor, and then you have 1A coming in from the driver to the blue wire of the first motor. Red wire of the first motor gets connected to the blue wire of the second motor, and then the red wire of the second motor gets connected to 1B on the driver board. And what is the difference? The main difference is that if you connect your coils like this in series, you use the same current. Whatever current is required by one motor, let's say 1 amp, that same current would go to the second motor, so you only need 1 amp total current going through both motors. But you may need to increase your voltage. Usually the motors that we use operate at 5 volts, 3 volts. There are different voltage ratings for the motors, and really it doesn't matter much as long as it's less than 6 volts for the series connection, because you still want to apply full voltage that you can apply to the motor. So if you have something more than 6 volts, then combined 6 volts here and 6 volts here will give you 12 volts. If you have more than 6 volt motor requirement, so let's say your motors require 8 volts, then 8 plus 8 would be 16. That's more than the typical 12 volt circuit that drives motors in a usual printer. Unless you have a 24 volt circuit, then you're good up to 12 volts per motor. But anyway, let's presume that we have 5 volt motors, so we're good here. As long as the voltage of the motor, or the voltage rating of the motor, is less than 12 volts, you're good. So here we would drive this set of coils with 1 amp, and we'd have 12 volts going across both coils. In this case, when we connect motors parallel, your current is getting split. The half of the current is flowing through one coil of one motor, and the other half is flowing through the coil of the other motor. So what it means in practical terms is that if you have 1 amp motors, you have to supply 2 amps to drive these motors. And that's when we run into problems with the driver boards, because they are rated for a certain amount of power. Usually that's up to around 2 amps depending on what driver chip you use. And the higher the current that you output from your driver, the more the driver chip will heat. So then you run into problems with the driver chips overheating, and possibly your motor stalling because the thermal protection of the driver chip kicks in and basically stops current from flowing. So if you have high current motors connected in parallel, then you may run into problems with your driver chip overheating. But the wiring for these two motors connected in parallel is much simpler, because again, you connect the two of the same color. All the wires of the same color get connected together and they go to the corresponding terminals. Whereas this, you have a little bit of back and forth between the two motors. It's a little bit more complicated. So most people use this arrangement of connecting your motors in parallel. It's just simpler, and usually, hopefully, you have a motor that requires little enough current that you can do this and still not overheat your drivers. So these are the two possible ways of hooking up your motors. And now Again, let's go back to hooking up your single motor to your driver board. Like I said, 1A goes to 1A here on the driver, 1B to 1B, and so on. So let's connect our motor like that and then see what happens. Let's experiment with this a little bit. So here's my motor, just a little slipper motor with a tape attached so we can see in which direction it's spinning. Here's the wires coming in, and I already know that these two first wire, the blue and yellow, are one coil, and the other two wires are the other coil. So I can connect my outputs from the driver board just straight through. That's connected, and my circuit is already set up, so I can apply the input voltage, and I can enable the motor, and it's spinning. So it's spinning counterclockwise. Now let's see if we flip all the wires around, and I'm using this wire to drive the enable pin on my driver board. I don't want to make any changes to my motor wiring with the motor enabled, so I'm switching to disable the driver. If I was doing any plug-in unplugging with motor enabled, I could fry my driver's chip. So now with motor disabled, I just flip around my connector, and the motor was spinning counterclockwise. With the connector flipped around, it's spinning clockwise. Now let's go back to the original setup. And again, motor is spinning counterclockwise. So if you need to reverse direction of your axis, let's say that your z-axis is going up when you expect it to be moving downwards, then all you need to do is flip this connector. Or you can change your settings in the firmware. That's also an option. If you don't have access to firmware, if you cannot change that and re-upload new firmware, then this is an option for you. Now let's see what happens if we flip around connection of only one coil. So I'm leaving one of the two coils, and it doesn't matter which one you change. So I'm leaving one coil as it was connected originally. I flipped around the other coil, and let's see what happens now. Again, the motor changed its direction. First it was spinning counterclockwise, now it's spinning clockwise. So even flipping just one coil will result in motor changing direction. But now, and that's the problem that you may run into when you have these funny multiple connector motors. See, this is my motor for the z-axis with built-in lead screw. And this is the one that kind of has center taps. It has 6 pins here, but only 4 of them are wired. So the center tap pins are missing here. We don't care. But the tricky part is that this connector, this motor, has the coils not in sequence. So blue and green, as you might think, are not for one coil, and then black and red for the other coil. Actually, on this connector, blue and red is one coil, and green and black is the other coil. And so if you presumed that these are your two separate coils, black and red and green and blue, and just wired them to your driver, your motor would not spin. So let's see what happens if you do that with your motor. So here I have blue and yellow is my one coil, and green and red is the other coil. So now I'm going to unplug the beginning of each coil. These wires were in this place, so I'm not switching these, but I'm going to switch these two, the beginnings of the
two coils. They were sitting here. Now I'm flipping them around like so and plugging them in. And let's see what happens if I try to run this motor with coils not connected correctly, or wires not connected correctly. See, the motor is not spinning, it's just buzzing back and forth. So if you connect your motor and it's doing this, just buzzing and not moving, that means that your wires are crisscrossed. You need to switch your wires around so that the motor moves. Now let's see what happens if we only, well, I'm not sure. Let's give it a try. That's a little bit risky if I leave out one of the coils disconnected, but it should be okay. Let's see what happens if I just connect only one coil and leave the other one disconnected. Again, buzzing. So either when your motor is not moving and only buzzing, either one of your connections is open or you've crisscrossed your wires, and if plugged in correctly, your motor will be spinning. Now actually let's grab a multimeter and see how we can tell which set of pins is a coil. So I'm going to disconnect my power, disconnect my motor, and for these plugs that's kind of easy because you have these metal tabs here. Otherwise you have to attach some wires that you can stick inside of the connector, attach them to your probes. So let's grab a multimeter, set it to ohm range, to resistance measurement, and let's connect one wire to the first pin and the other wire to the second pin, and we measure resistance of 3 ohms. Alright, then I move to the third pin, no resistance, open circuit, and the fourth pin, again open circuit. So this tells me that these two first pins are one coil. So then of course the second two pins would be my second coil. And you can't really tell which wires are the beginning of the coil, which are the end. Doesn't really matter, as long as you know which pair of wires is one coil and which other pair is the other coil. That's all you really need to know. And all you need to figure it out is a multimeter. Just make a simple measurement and you're good to go. So yeah, if you plug in your motor and it's buzzing and not moving, that's what it is. Your wires need to be moved. And you can stick in a screwdriver, flat blade, small screwdriver, in here in this tab and lift it gently. Or if you have tweezers, that's even better. Something small, they can stick under the tab and gently lift it just a little bit and slide out the connector, and then slide whatever other connector you need to move around and just slide them back in. So that's how you can rearrange wires on these connectors. Now some other connectors are more difficult, like on this one. Well, you can still do this, but it's much trickier because the connector is so much smaller, but it's still doable. And again, on this one, see how one way you can tell which wires are which pair is because here on this end you have blue and red and then green and black. And so here blue and red will be your one set and green and black is the other set. Not what you would think, like this. So hope this helps. If you have any questions, post them in the comments. If you like the video, give me a thumbs up, subscribe to my channel to be notified for more videos. If you didn't like something, please post a comment. If you just give me a thumbs down and dislike, I won't really know what you didn't like, so I won't be able to make improvement in my videos. So see you guys later.